Alex, this week you did a CNCF webinar on the storage landscape for containerized applications. And there were some questions we didn't get to, so we thought we'd put together a really quick video on those questions. So the first question, is there an argument that a stateful application is a bad use case for containers?
So this is a very common question and comes up in many discussions. The answer is that storage for cloud-native applications is different from traditional storage. And so when you have stateful applications, you are usually building on top of your container base where you've made your containers portable, and you're building on top of your orchestration base where you've abstracted out your infrastructure and you've applied composability and to your application. So cloud native storage provides all of those advantages to the storage layer too. And this doesn't mean that all cloud native storage solutions need to be solutions that are run within your orchestrated platform. But it does mean that it gives you the extra flexibility to deploy all of the services just exactly as you need them.
Cool. So the next question, is it possible to access the same volume across multiple pods?
So again, that's a very common question. There are two different types of use cases. Some applications like databases are only ever run in one particular pod, for example, but other distributed applications might need to use some sort of shared file system. So within Kubernetes, you have the concept of write once volumes, which are only accessible on one node at a time, and you have the concept of write many volumes which are accessible across multiple nodes at the same time. So shared file systems like NFS, for example, allow you to do this.
Cool. Next question, how are storage access controls implemented when using persistent volumes?
So storage access controls can be quite tricky because there usually is a level of integration required between the functionality that the storage system provides and the functionality that Kubernetes is assuming. So one of the big differences between different types of storage systems is that some of the traditional storage systems tend to provision storage to individual nodes. So access is controlled by which node can access the storage. In other more modern storage systems, the storage is the access controls are managed by application, and this allows a much more granular view of the storage access controls that can integrate into the policies and the namespaces that are managed by Kubernetes.
Cool. So next question, when you claim for specific storage space from persistent volumes, what happens if the data exceeds the storage space?
So that is functionality that is being developed and integrated right now. So the new CSI interfaces of Kubernetes, CSI being the container storage interface, allows Kubernetes to resize volumes. And the idea is that when this functionality is deployed, that resize functionality will allow you to dynamically grow volumes, assuming, of course, the storage system allows the dynamic growth of the volumes.
Okay. And is it possible to thin provision storage for containers?
The answer is yes, but that is strictly a feature of the underlying storage system. So some storage systems allow thin provisioning, and what this means is that the volumes only consume the amount of storage based on the amount of storage that's actually stored within the volumes, as opposed to the total size of the volumes. And this is beneficial because it allows you to over-provision capacity. But and while this is transparent, if the storage system supports it, it is storage system specific.
Okay. And last question, who is responsible to erase or delete the content of a volume or delete the volume in case the volume and data is no longer needed?
Right. So in the case, so the volume can be deleted through standard Kubernetes semantics where you can remove a PV, and when you delete the claim, the PV can be removed. There's also a deletion policy which can be attached to a storage class, which defines whether the volumes survive the storage class being deleted. We also have some interesting concepts when volumes are encrypted. So, for example, safely deleting a volume can be sort of cryptographically secure if the volumes are encrypted by simply removing the keys, because once the keys are unavailable, then the data in the volume is also unavailable too.
Cool. Now, final question that I'm adding to the conversation is, if I want to get involved in the CNCF storage program, what could I do?
So the CNCF Storage SIG is a group which was created by the TOC a few months ago at KubeCon Barcelona in June. And we're there to help create some of the information needed to help the onboarding of applications into the cloud native space. We're also work quite diligently with some of the projects and reviewing the projects to help the TOC make decisions as to whether to onboard projects or promote projects. All of the SIG meetings are public. We meet twice a month. The calendar is on the CNCF website, and the CNCF SIG also has its own page on github.com. So if you just Google CNCF Storage SIG, you'll find all the information there.
Cool. All right. Well, thank you very much for answering those questions.
Thank you.